Okay, so in this video we're going to pick up from question 4b. There's plenty to do here by itself, so 4a was in an earlier video. Maggie here has got a sample of n bulbs. Again, she's interested in how many of them are blue. So I've already written a little bit here. M is our new random variable. M is the number of bulbs out of n that are blue, and that's going to be a binomial distribution where n is this unknown value n, and p, the probability the bulbs are blue, is 0.36. That was given earlier in the question. So we've got this binomial distribution with an unknown n, and then we're told one fact to help us work out n. We're told that under a normal approximation, the probability that m is greater than 244 is 0.0521. So we need to figure out the details now of what is this normal approximation. So remember, you can go from a binomial to a normal if you calculate the mean value, which is np, and if you calculate the variance, which is np1 minus p. So for us, the mean is n times p, so that's just 0.36n, and the variance is 0.36n multiplied by 1 minus 0.36, and that is 0.2304n. So we've got a mean and a variance. We need a letter for this normal approximation, this normal distribution as well, so let's call it y. That's a normal distribution where the mean is 0.36n and the variance is 2304n. Okay, so far so good. Another important thing to remember is that when you go from a binomial to a normal distribution, we need one of these so-called continuity corrections. Okay, there's 0.5 that comes into your probability question. Now we had the probability that m is greater than 244. So my way of thinking about that is a little number line, 244, 245, 246. We want values that are greater than 244, so we want to cut the number line here at 244.5. So in our normal world, we're told that the probability that y is greater than 244.5 equals, now what was it before? It was 0.0521. So we've taken this binomial statement, and with that continuity correction there, rewritten that statement for our normal approximation. Okay, now another complication here is, in this normal distribution, we don't know the numerical value of the mean or the variance. So we need the underworld. We need to drop down into the Z distribution. So we're going to draw a couple of pictures so we can make some progress there. So we're going to draw Y first of all. Y distribution has a mean on 0.36n. I'm not going to copy the distribution again. But we're told that the probability being greater than 244.5, so this area, this probability here, is 0.0521. So underneath, when we go down into our Z world, remember Z is always centered on 0. Z is a normal distribution, 0, 1. But we can shade the same area, 0.0521. But we've got this unknown Z value at the moment. Okay, so the process is, first of all, we need to do a little inverse normal on the calculator. Down here in the Z world, it will ask you for sigma and mu. Sigma is 1, mu is 0. It will ask you for the area to the left. So this is 0.9479. And it should give you a Z value in return, which is 1.6248. Okay, the calculator will give you that value. And then we'll come back to our algebra and our working and the important equation that connects these worlds. X equals mu plus Z sigma. So remember, X is a real data value, that's the 244.5. Mu is the real mean, that's 0.36n. Z is the only thing that we take from the underworld. That's 1.6248. And sigma, if we look back at our distribution, this is variance. This is sigma squared up here. So sigma is the square root of 0.2304n. And that's an equation that we're going to have to solve to find n. So this is a key moment. The statistics has all happened. We're now just purely solving algebra. And it's not the nicest algebra, but it is just algebra from here on. So we'll scroll down so we've got some more space, and we can solve that equation. I think the first thing I'll do is simplify this term a bit. Let's multiply 1.6248 by the square root of 0.2304. And if you multiply just those numbers together, you get 0.78. You get 7799, but we round that to 0.78, and it's still got a root n term there. I'm going to rearrange that slightly. So I've got the n term, then the square root term, and then the 244.5. It's just a constant term. And if you notice, this is actually a quadratic. It's a hidden quadratic because it's a quadratic in the square root of n. Now I'm going to be lazy in solving this. I'm just going to put those coefficients into the calculator in the quadratic solver, and it will tell me two possible values for root n. So if you type in those coefficients, it should solve you to tell you that either root n is 25 or root n, I think, negative 27. It's a negative number. We can completely reject that. And if root n is 25, then n must be 25 squared, or 625. And we're done.